Now we've arrived at the free response question of the June 2018 Physics Regents, starting with part B2 with questions 51 to 65. So these are the first 15 free response questions. The last 20 will be in part C in the next video. And we start this section with a deceivingly simple measurement type of question set. It looks simple at first, but they kind of throw a curveball with these two vectors that are over 90 degrees apart from each other. They're not exactly vertical or horizontal entirely. Well, we have a complete vertical vector, but we have one that's at an angle and it's not quite 90 degrees between them. We're used to seeing less than that. But nevertheless, it's still doable. So we start with determining the linear scale using the diagram. So these are pretty much drawn to scale with each other, and we had to use, you can use either a protractor or a ruler, whichever measurement tool is provided to you at the Regents. I know my kids are provided protractors with a straight edge attached to it. So I think the answer booklet puts it in centimeters, so we got to use the centimeter side of our measurement tool. And unfortunately, I can't find an image of a transparent protractor to show you guys, or a straight edge. So I'm just going to tell you right off the bat what the linear scale is, not the linear scale, but the actual measurements. So this 32 newton vector comes out to 8 centimeters, whereas this 20 newton vector comes out to 5 centimeters if you measure them accordingly. Now, what both of these have in common, 8 over 32 divided by 8, we need it newtons per centimeter. So 32 newtons over 8 centimeters gets you 4 newtons per centimeter. The same thing with the 20 newtons for 5 centimeters. They both have the same scale of 4 newtons per centimeter. And that is your answer for number 51. Number 52 is the tricky part in sort of drawing the scaled resultant vector, and we gotta label it R. Now there are two ways you could do it. You could do it the parallelogram method, because if you draw identical vectors on the other side, such as vector AP on the right side and vector PB on the top side, it makes a parallelogram and you're able to draw across from corner to corner the correct resultant vector. Just know that your resultant vector should be pointing sort of in the northeast direction, because vertically you're mostly pointing upward, with vector A being the longest vector here, versus vector B being shorter, pointing downwards, but vector A wins out on the vertical side. And then on the horizontal side, it's all pointing horizontally to the right with vector B, nothing in vector A. So we're going to pointing northeast, generally up and to the right for our resultant vector. Now, we have to draw it kind of almost as close to what it should be. So we need exactly the correct length. We're allowed a little bit of a acceptable range. But here's one way you could do it to sort of draw this parallelogram. Or some of you might have learned it as the tip to tail method. So these vectors always have to be added up by drawing from tail to tip. So we start with this one. At the tip of this one, you draw the next vector down this way. Or if you decide to start with vector B, start here, you draw vector A to combine them. And then you go from tail of where you started to the tip of where you end to draw the resultant vector. Alright, so I'm going to draw it this way. For me to draw vertically straight, I'm going to replicate vector A here. Approximately like this high. I'm going to trim it down there. And so this is my version of vector A adding with vector B. From here, the tip of vector B, you draw your next vector, and that's how you add them up, from tail of where you start to the tip of where you end. And that's approximately how your resultant vector should look like. And if you measure this out, this comes out to about 7 centimeters long. You could be close to that, 7 or 6 centimeters. I've seen kids try this with 6 centimeters. It should be leaning closer to 7. And so using that now, that's question 52 is drawing. Now question 53 says we have to determine the magnitude of this resultant force. So how many newtons is vector R now, the resultant? So we're going to go back to 51 and use our linear scale. If the resultant vector is 7 centimeters long, then it's going to be equivalent to 28 newtons. Now, what happens if you don't get 28 newtons? What if you get a different measurement length for vector R? Well, as long as you use the linear scale and get a number that's appropriate with your answer, then it should be okay. You should still get the point. That's the beauty of free response. Okay, question 54 to 56 is another problem set. Here a student pushes a box weighing 50 newtons 6 meters up an incline at constant speed by applying a force of 25 newtons parallel to the incline. The top of the incline is 2 meters higher than the bottom. Calculate the total work done on the box by the student while pushing from bottom to the top of the incline. And it's a 2-point question, so we need to show work. The way to do it is first you need to include the equation you're using, as the instructions said. So we're doing work equals force times distance. That's our equation. Then we need to substitute with units. Since we're calculating for work, I'm going to keep W there. Our force, the force that's doing the work, pushing the box, is 25 newtons. The 50 there is the weight. And the distance the box actually travels is 6 meters, being pushed along the 6-meter ramp. So 25 times 6 will get you 150 joules. Showing these things will get you the 2 points. Number 56, describe what would happen to the total work done up the incline if the coefficient of kinetic friction between the box and the incline were increased. So coefficient of kinetic friction plays a role in the frictional force. So mu is our coefficient of kinetic friction. If mu increases, so does the frictional force, and that goes against motion. So if you have more friction going against you, then clearly you have to do more work. So our answer here is describe what would happen to the work done. Work would increase if you increase friction. Number 57 asks to draw the reflected light ray. So it enters here from glass and it hits the surface interface between glass and air. It's going to reflect back down into glass. And the relationship here is that the incident ray has an angle that's equal and opposite to the reflected ray. So you should approximately draw it at the same angle. This is why you need a protractor. I'm just freehand drawing it, and it looks just about where it needs to be. If you draw it here, then it refracted through into air and bounced off the normal, but that's not accurate at all. If you drew it in this quadrant here, then you're showing refraction, where it refracted through the interface and bent angles. Or if you draw it at the same angle, it will be exactly a straight line. But it has to be in this quadrant to show that it reflected back into the same surface at the same angle it arrived at. Okay, here we have 4 question points, but 2 questions actually, 2 2-point questions. So we got to show work for both of them. So number 58 to 59 says we have a current in a wire. So let me start with this, the setup. We have current I being 5 amps. Calculate the total amount of charge in coulombs. So we need this, Q. And the time interval is 36 seconds. So I equals Q over T. That's the equation you're using. 5 amps equals Q over 36 seconds. Do your algebra correctly, 5 times 36, and that'll get you, I'm doing this in my head, 180 coulombs. Now, number 60 to 61, now we're dealing with springs. Another 2-point question. Gives us a spring constant of 100 newtons per meter. So that K value, spring constant, is 100 N/m. Possesses 2 joules of elastic potential energy. So that's potential energy subscript S for in a spring, and that's 2 joules. And it has that much energy when compressed. We need to figure out the change in length from its uncompressed length, so that's X. So we're using the PES equation, as some of you like to call it, 1/2 kx squared. So 2 joules equals 1/2 100 x squared. You get that x is equal to 0.2 meters. That's how much it was compressed. Okay, number 62 to 63. Let me start with that. A monochromatic ray of light with a given frequency, that's not really important at all, travels from air into medium X. The angle of incidence of the ray in air is 45 degrees, and the ray's angle of refraction in medium X is 29 degrees. Calculate the absolute index of refraction in medium X. So light is traveling. Let me draw the diagram first. And here's a visual of what's happening here. Light is traveling from air into a new medium X. And so since we're dealing with this refraction, we have to use Snell's law equation. N1 sine theta 1 equals N2 sine theta 2. So let's just use angles and indices of refraction. So we start in air. So the left side, the one side, will correspond to air. The right side will correspond to X. N1. So we start in air, and you have to look that up on the reference table, but this one you should probably good to know offhand, and that's 1.00. That's the N value of air. Sine 45 degrees, because that's the angle that is associated with air. And then we're looking for the N value of X, that's our unknown variable, and then sine of 29 degrees. And you should get your N value to equal 1.46, and this should make sense. Air is our lowest N value. If you get something that's lower than 1.0, then you did something wrong here. Okay, 64 to 65. An argon ion laser emits blue-green light having a wavelength of 488 nanometers in a vacuum. So to give this the wavelength lambda, 488 nanometers, that's the same as 488 times 10 to the negative 9 meters. And we're looking for energy in that photon. There's only one equation, E equals hc over lambda, or hf if you have frequency, but in this case we have to use this form because we have lambda. H is Planck's constant, that's on the front of the reference table, that's 6.63 times 10 to the negative 34 joules seconds. And then the speed of light is c, 3 times 10 to the 8th meters per second. And then lambda is 488 times 10 to the negative 9 meters. So do not forget the units, especially for these constants. At least they're given to you on the reference table. And so calculate, plug and chug, and you get your answer to equal 4.08 times 10 to the negative 19 joules. And that's your answer for number 64 to 65 for the full 2 points. And that's the end of section B2. Now we're going to approach the final section, part C, with the last 20 questions.